The advantage of R is that it's a very powerful software, and my forecast is that it will keep on. It will keep on continuing its uh, facility, its power, because of so many people that are using it, and of course it's free, and then so many people contributing to it. Okay. In this subject, we're going to both learn R and Python also. So if I may, guys, may I request you to also start already learning Python. We're going to use Python and Jupyter. Our IDE will be Jupyter because there are several IDEs in Python. In R, you have also several IDE or integrated development environment, but the most popular one is RStudio. So for Python, there are also many, PyCharm, Spider, but we're going to use Jupyter, Jupyter. Okay, so please start also downloading Python and also download. You can use the, actually, you can just search lang guys, Anaconda, no? Anaconda. Okay, when you download Anaconda, it will come with it the Python itself and Jupyter. So you just need to download one, Anaconda. Okay, download the latest version. Okay, so let's now go back to our discussion. Okay, last time what we did was to download or access the data that we were using, wage. Okay, so I hope you have already downloaded that. Okay, so dali ang mag-chat dito. Mamaya na lang, Julia, na yung attendance. After class na lang, ha? I'll check attendance later, guys, for those of you who just came in or were having difficulty entering our session. Okay, so I have already downloaded it, guys, wage. Okay, and let me just once again view the wage. Okay, we said that when we view a particular object, it will give us, okay, it's taking quite some time. Okay, so here's our data. Okay, we have education. The variables are education, experience, tenure. We have here race, gender, and civil status. These are categorical variables. And then number of dependents and hourly wage. So in this activity, we're going to regress hourly wage. We'd like to determine whether hourly wage can be predicted using these factors: education, experience, tenure, race, gender, civil status, and number of dependents. So that will be our end goal for this particular data set, wage. Okay. So last time we learned some basic functions, like when you use names, it will give us the names of the variable of this object. Okay. The head function will give us the first 6 rows. If you don't identify, the default is 6. But if you identify how many rows will be generated, then it will give us whatever the number of rows you prescribe. And tail will give us the last 6 observations, unless you define it to be such, in this case 3. Okay, so we also learned how to subset given guys the object wage. Okay, the brackets here is used for subsetting. So we said that if we're going to subset the object wage, and we define 1 to 10, the first number here is your number of rows, and the second number is your columns. So the first 10 rows and then all the columns. That's what this means. And it's the same as your head function. Okay. Now, what does the structure function give us? So let's just quickly run this. Okay, structure structure of wage, it gives us some description about our data, and we're told that the structure of wage is a data frame. Okay, if you recall, guys, a data frame is a matrix form. It's a rectangular form, two-dimensional. You have rows and columns, where your rows are your observations and your columns are your variables. Okay, that's a data frame. And the data frames, the name of their columns are this one: education, experience, etc. And we're given a definition what type of data they are. Education, experience, and tenure are integer. And the others are character, and again, another integer, and hourly wage. We can, of course, we can change this accordingly. Okay, remember the coercion rule. Okay, integers can be coerced into numeric, okay, etc. All right. So last time we also did this. Now I think some of you are having difficulty with the psych package and the paste text package. Were you able to address that, class? Were you able to address the psych package? Were you able to install the psych package? Okay. Because we're going to, in this code, okay, if I run this, control enter. Okay, describe. It's not yet running. Did I already? I think I installed the packages already. Yes. Okay. Now, guys, just a reminder, when we have our classes, the last data that we're using, make sure that when you come to class, you already have installed or required the packages. Okay, access the packages, and then also imported the data, because when you close this, okay, you will lose the access to the data, so that when you open it again, you have to import the data once again. Okay, so we're now here. Okay, the structure, and we're done with that. Okay, the psych package also gives us some descriptive statistics information. Okay, so let me just increase the width of this. Okay, let me run this again. Okay, this is the package. The describe function is coming from the psych package, and it will give us the some descriptive statistics about our object page. Okay, so here, these are the index of the variable. We have 8 variables. Each one of them have 8 observations, and that should be what a data frame is, guys. A data frame should have equal number of observations. Okay, otherwise it becomes a list, okay, or another data structure. And you have here the mean for each of the variables. Of course, race, gender, and civil status are all character. So the mean, the standard deviations, and their medians or the trimmed median do not have any meaning at all. Okay, so these descriptive statistics are only relevant for the numeric data. Okay, and also you can see here also the minimum, the maximum, the range, which is just the difference between the maximum and the minimum, the skewness, and the kurtosis. Okay, and we can also run the descriptive statistics using the paste text package. If I run this, okay, so it's another output for your descriptive statistics. Okay, there are several ways by which you can generate the descriptive statistics. Okay, using different packages, using different functionalities. Okay, now what's good in R is that we can easily plot Using the base R, we can plot whatever object we would like plotted. So here, okay, here we're asked the question, can we plot this? Okay, plot education, hourly wage, and then we're on the x-axis is education, on the y-axis is hourly wage, and then the title of the main plot is scatter plot of education and hourly wage. Will this run, guys? No, it will not run. Why? Why will this not run? Anyone? Why will this not run? This will not run because R does not recognize this education and hourly wage. Do we have an object called education? We don't have one. Do we have an object called hourly wage? We don't have one also. Okay. I'm sorry, before we go to the plot, let me just backtrack a bit. There are other ways by which you can generate the descriptive statistics. We can use the scheme R. I think we loaded the scheme R package. For the scheme R, okay, we can make use of the scheme function. A scheme function. Okay, let's run this. Scheme R. That's a package also. And then scheme wage. Let's see what this gives us. Okay, this is also a descriptive statistics type. Okay, there. And what's good about this is that it gives you it's like a sparkline column chart of the variable. Okay. So here we have, let's just quickly look at the summary of the scheme R. It already distinguishes between your character variable and your numeric variable. Okay. So we have here the number of rows and the number of columns. Okay. And it's a variable, the character, a variable type character. You have three variables that are characters, a race, gender, and civil status. Okay. And then it tells us what are the unique values, okay, what are missing. So none is missing. What are the unique values? Here it's 2, which means that there are 2 unique values for race. I think it's white and non-white. Gender is also married and single. Civil status, male, female for gender, and married and single for civil status. Okay, so this is one way also to present your data, the descriptive statistics. What's good with the scheme R is that it separates already the character variables. Okay, no need to compute for the, let's say, the standard deviation, the mean, the median of the character variables, because they don't mean anything anyway. So you have 5 variables. Education, experience, these are now your numeric variables. So complete rate, 1, that's 100%, so no missing. You have the mean, okay, the standard deviation, okay, percentile, okay, where's that? So you have 0 percentile, P0. Okay, you have, this is the first quartile, P25. This is the second quartile, this is our P50. Third quartile, P75, and then your maximum. P0 is your minimum. Okay, and then you have a histogram of the 5 variables. Okay. All right. So as I mentioned a while ago, guys, this will not work because R does not recognize this education and hourly wage. Education and hourly wage are part of the wage object. They are in that wage object, and R is not able to recognize this. So how do we now modify this? Okay, so we can do this plot. Okay, and then we have to identify that these variables are coming from your wage object. So there, guys, wage dollar object. So we're telling R that we'd like to plot, the x-axis should be the education coming from the wage data set. This will be recognized because R knows that there's an object called wage. Okay, then also wage, then underscore, dollar. And then once we type the dollar, you notice that it will give us a different variables for wage. Okay, so let's choose the HR wage. Okay. Any questions, guys? And then maybe let's let's put in more details. So let's copy this. Let's copy this main. I'll copy also the comma. So this just gives the main title of your plot. Okay, what else can we include here? Maybe we can also include the X lab or the X label. The X label, we can put it as years of education. Okay, because we're plotting the education in our X-axis, and for our Y label, Y lab, we can call it hourly wage. Okay. Okay, and then when we plot, guys, in base R, okay, let's stop there for a while and let's see what happens with this plot. Okay, can we plot this, guys? Okay, and it's plot wage. Okay, what are we missing here, guys? What are we missing here? Error, unexpected symbol in, what symbol did I? Hourly wage, okay, main.
Quotation mark poster for the scatter plot of education.
Ah, yeah, oh, I missed the, close quotes, okay? So R is quite sensitive. So main is equal to, and okay, here, comma, X lab, okay, there, okay? So our main title, the title of the main plot, the title of the plot is scatter plot of education and hourly wage. Okay, mali na naman to. There should be a close quotation here. Okay. And then, what did I do? Okay, I already have X label there. And then the X label is years of education, and then Y label is hourly wage. Okay, so let's see what happens here. I'm going to plot this. Okay, figure margins too large. Now, when that happens, guys, you may just increase this. Okay, to give it more room. Okay, and then I'm going to run this. There. Okay, so we can see here, guys, that this is now the plot. Very easy to plot in our studio. Okay. You can see here that our hourly wage, okay, the maximum is about 25. Okay, we can actually, let me just decrease this a bit. Mahirap ano sa pagkuha ng ano. Okay. Let me just adjust the size a bit. Okay. You can so it will appear, the plot will appear in the plots window, in the files window pane, and then you can increase the size. Okay, so this is zoomed now. Okay, or you can also export this. Export, you can save it as an image, save as PDF, or copy it to the clipboard. Okay, you can do several things with this file. Okay, now what do you notice about the plot? It looks like there seems to be a not so clear, no, but there seems to be a positive correlation between hourly wage and education. As education increases, the hourly wage seems to increase also, but it's not really that apparent. The relation seems to be very okay. Although it seems to be a positive relationship, but there are really many variances. Okay, magkakaiba talaga, no? Across the different years of education. Okay, so now guys, just some okay. Notice guys, what did I do? So in the console, okay, you cannot really go back, guys. You cannot really go back to the previous codes. So you just have to. I'm pressing now the arrow, upward arrow and downward arrow. So here I was able to go back here, and there's we can add this function PCH. No? So that's a plot character, and when you plot in R, there are several plot characters. Let's just try. If it's plot character 1, Control Enter. So it's the same. PCH means plot character. So what if we try plot character, let's say 10? Okay, why is it not plotting? Okay, there. This is supposed, guys, to change the plot. Notice now the characters that was used to plot hourly wage and education differed now because of the plot character. For our purposes, what we would normally use is plot character. We can use 19 because that's what was used a while ago. I think that's default. Okay, 19. That's quite dark. Okay, so plot character, guys, I think it's up to 24. So you can explore the different types of plot character. So it's a 24 is a triangle. So you can change the appearance of your plot by including this plot character. Okay. Okay. Any questions so far, guys? Any questions?
None, sir.
Okay. Thank you. Now here, guys, maybe we can add one more thing here. Notice that in our plot, our hourly wage, years of education, our x-axis is only up to 15. We can modify this a bit by using the axis function. Okay, the axis function, and then 1 will refer to your x-axis. Okay, so here we're changing the x-axis 1, and we want the minimum to be okay 0. The minimum is still 0, but the maximum is 20. Okay, and then by how much do we want the increments to be? Okay, we can still maintain the 5, 5, 10, 15, 20. So let's just identify 5 there. Okay, wait. Huh? Okay, let me run this here. Okay, I'm going to copy this here. Control C, Control V. Okay, so I'm going to run these two together, the plot and the axis. Control Enter. Okay. All right. Now, why did it not? Hindi siya nag-run. Okay. Hindi nag-run yung axis. This is x-axis, minimum 0, maximum 20, increments of 5. Let me run this again. Ayaw mag-cooperate, no? Dapat magto-20 dito, guys. Ay! Oh, bakit andito siya? Why is 20 here? Something's wrong. Okay. Anyway, guys, naglolo ko yung... how about in your case, guys? Did the 20 appear here? Nag-generate ba ng plot na ano na 20 yung ano yung last dito kasi dito naglagay which is wrong. Dapat 20 dito sa dulo. Minimum of 0, maximum of 20, increments of 5. That's what the plot should appear to do. I'm having a problem with my plots. How about in your case, guys? Okay ba siya?
Sir, same lang.
What do you mean same lang?
Yung 20
Same
nandun rin
problem.
po sa position ng 0.
Hindi, ano? Bakit kaya? Ay! Wait. Mali. Sorry, mali yung syntax ko, guys. Check. Okay, let's check that. Axis. Okay. So axis. So side between X and Y at. Okay. Position. At. Points at which are to be drawn. Labels, tick mark. Position. Line. Okay, medyo at labels. So dito dapat at. Let's see. Example ba siya? Okay, wala akong nakikitang example natin na pwedeng sundan. Vector ba itong ano? Moment guys. The points at which the tick marks are to be drawn, non-finite, by default, are computed. Okay, by default. Okay. So sige, ang gawin natin, so dapat, hindi pa pwede ito, no? Kasi dapat yung at niya, okay, sige. So, yung at gawin natin, let's sequence it. SEQ guys, sequence. Okay. Sorry about that. No? So 0 yung minimum, 20 yung maximum, and then increments of 5. Okay, so what's this guys? Axis, x-axis to. Tapos isi-sequence natin yung yung at function niya, okay, ang minimum will be a 0, ang maximum will be 20, and the increment will be 5. Okay, so let's run this. I hope this is okay already. Wala pa rin. Wala pa rin. Bakit kaya? No? Okay, sige. Iwan na muna natin yan, guys. No? Okay, I was just looking at improving the plot. Sige. Okay, sige guys. Iwan muna natin and then I'll try to decipher. Okay, kung saan ako nagkamali dito. Hindi kasi nag-appear yung 20. Dapat yung tick marks niya at 0. Then, yan, 5, 10, 15. Wala yung 20 increments of 5. I'm looking at the previous, wala. Okay, apologies guys for that. Okay, hindi ko ma-decipher kung bakit. This should have worked. Kasi ginagawa ko lagi ito eh. Naglalagay, pag ina-adjust ko yung axis, especially on the x-axis, from 0 to 20 by 5. Okay. Hold on guys. Sorry guys, may knock on the door lang. Okay, so let's see. Okay, now let's go to the first thing that we're going to do is do simple regression. Now I understand from your FINSTAR, you used Excel in order to generate simple and multiple regression. Now we're going to use R in order to generate both simple and multiple regression and other types of general linear model. Okay, the function that we're going to use is the LM function. Okay, so if we run this, okay, so make it a good habit, guys. If you want to learn more about a particular function, okay, the help function will give you some good information about it. So the LM function is from the stats package, and LM is used to fit linear models. Can be used to carry out regression, analysis of variance, analysis of covariance. So many uses for LM, and this is the syntax. So you have the formula, the data, if there's any subset, if there's any weights that you need to include, etc. Okay, so for our purpose, we're going to use the wage object in order to regress. Okay, first we're going to regress hourly wage on education first. So simple regress lang muna. We'd like to see if hourly wage can be explained by education. Only one variable. And if it's only one variable, we say that it's a simple linear regression. Okay. All right. So what's this, guys? Do you have this in your file attached? What's attached? We use the attach function in order to inform R that all the variables that we're using comes from the wage data set, from the wage object. As we know, there are 8 variables for wage. Okay, so 8 variables yan. When we use these variables, education, experience, we should always attach the object wage to it. As you noticed a while ago, when we just use education and hourly wage, it did not recognize the plot function. It did not recognize the education and the hourly wage because these are these are variables that come from the wage function, the wage data set, the wage object. Now, if you want to avoid having to identify each of these variables from the wage object, then the way to go about it is to use this function attach. Okay. So what will happen if we attach? What will happen if we attach the the object wage? When we attach the object wage, then when we refer to the variables in wage, it will recognize it even without using the wage, the one that we did a while ago, wage dollar, okay, wage dollar gender, wage dollar civil status, etc. Okay, you follow, guys?
Yes, sir.
Yes, sir.
Okay, so okay, let's first, so we attach first, we attach the object. So I said attaching the object means that if we refer to any particular variable here, let's say experience or hourly wage, etc., then R will already recognize that, okay, because we have used this attach. Later on, guys, now when do you use the attach? We use the attach if we're only using one variable, not variable, not one object, guys, in your analysis. Okay, so if you're using one object, just wage in our case, then it's okay to attach it. Okay, however, when you're working with several objects, it might not be good to use the attach function. Why? Because if you keep on using the other objects, the other data frames, okay, in your analysis, then there could be a problem if you attach the object wage. Okay, I hope that's clear, guys. Let me repeat that. If you're using several objects, okay, so several files, for example, okay, do not attach a particular object. Okay, but if you do it, guys, for example, you're going to analyze first wage, and then the next several codes will be about wage, then you can attach it. And then if you're done, if you're going to use the other objects already, then be sure to detach. So the opposite of this is detach. Okay, D-E-T-A-C-H, detach the wage function. When you detach it, guys, it means that R will no longer recognize the other variables that are found in wage. Okay, so why won't we use attach? We won't use attach, guys, if we have several objects that we're using at the same time. Okay, so for example, here I have an object called Apple. I have an object called wage or BPI. So since I'm working with several objects, several data frames, then I will not use the attach function because I keep on using several data frames, okay, at the same time. Okay, so this is only used yung attach, guys, if for this particular analysis, we're only going to use the wage data set, the wage data frame. Okay, so in this case, since we're using the wage data frame for all of our analysis here, then we can attach it. Okay, so after attaching it, guys, we can now plot. We can now plot the regression line. Okay, so how do we plot this? What do you think, guys? Okay, let's go back to what we did a while ago. Okay, the plot function here. Okay, this one. Control C. Okay. Wait, we haven't done the regression, ano? Okay, so let's do the regression first. Sorry about that. Okay, how do we now do a simple linear regression? Okay. What's your suggestion, guys? So we will regress hourly wage on education. Okay, it's always good practice, guys, to first take a look at the relationship between hourly wage and education. So R has plenty of functions that we can use. For example, the core function here. The core function. Okay, what does the core function do? This one. This is the core.ci. So this is coming from the stats package. It was the core function. Core.ci to one. Okay. Hindi nakalagay yung ano. Okay, core. Nag-intelligence ba siya? Okay, anyway. So let's identify the correlation. Let's take a look at the correlation between your two variables. Okay, because we'd like to create a linear regression, a simple linear regression between our variable hourly wage and our variable education. So let's generate the correlation, guys. And now, since we have attached, okay, we have attached the wage function, okay, so we can now write education and hourly wage. Okay, all right. Had we not used the attach function, guys, this would not have worked. Okay, hindi mag-work to. Okay, let me illustrate that. Diba nag-attach na tayo, no? I-detach ko siya, ha? Detach natin yung wage. Okay, I'm going to detach the wage. Okay. Detach the wage. Okay, i-detach ko muna. Detach. Okay, naka-detach na siya. And then I'll get the correlation between education and hourly wage. Okay, what happens? Error. No? Object hourly wage not found. Hindi nakita. No? Hindi nakita yung hourly wage and yung education at saka hourly wage. So let me comment this. Okay, comment ko na muna siya. And then i-run ko ulit si attach. So I run attach, guys, and then get the correlation there. Okay. So we find that the correlation between education and hourly wage is around 0.41. Okay. So is this a very strong relationship between hourly wage and education? Okay. It's quite a medium lang, ano? Medium to weak correlation. We would like, guys, when we do regression, we would like that the variables are really correlated. Gusto natin mataas yung correlation ni education at saka ni hourly wage kasi that means that your independent variable has a strong explanatory power to describe your dependent variable. So this one, 0.41 lang, okay? It's quite a weak or moderate correlationship between the two variables. Okay? Any questions so far, guys? Okay, so here, guys, what we did was to, pwede nilagyan, guys, sa notes, ha? Can easily correlation between educ and okay, correlation between them. All right. So, okay. Now, how about getting, guys, the correlation in wage? Can we do that? Correlation of the whole wage object. Now, take note that the wage object has, okay, di ba? May ano siya? May mga character variables. Can we get the correlation of character variables? Kasi we can only get correlation of numerical variables. Okay, you cannot get correlation of character variables. So if we get, guys, this one, and sabi error in correlation wage, X must be numeric, diba? But if you want to really get the wage, i-exclude natin si ano, okay? Exclude natin, guys, mag-insert tayo ng chunk. Exclude natin yung mga character variables. And how do you do that? Okay, correlation correlation nino ng wage. Okay? However, guys, isa subset natin. So ang kailangan natin na correlation will be education, experience, tenure, maybe number, if you want, number of dependents and hourly wage. Only the 5. Okay? So we're going to exclude first, second, third. We're going to exclude the 4th, the 5th, and the 6th column. So we're asking R to get the correlation of these variables except race, gender, civil status. We can do that, no? So sabi natin dito, correlation ng wage, and then how do we subset? We use the bracket, di ba? Bracket. The first number there should be the rows. Okay? So lahat ng rows, guys, kasama, no? All the rows, so we leave it blank. So comma, no? So this means, guys, leaving it blank means include all the rows and then include columns 1, 2, 3, okay, and 7, 8. No? So there are different ways to do this. One is to identify, kunyari C, and then 1, 2, 3, or ganito 1, 2, 3, comma, and then 7 and 8, or 7 to 8. Okay, so what will R do here? Ang gagawin ni R, kukunin yung correlation ng wage sa wage, okay? Ang i-include lang niya sa columns will be columns 1 to 3 and then columns 7 and 8. Let's take a look at columns 1 to 3. No? Okay, 1, 2, 3, okay, and then 7, 8. So yan, pwede yan, guys. So we can now get the okay, so this one, guys, ito, no? Okay, and let's run this. Okay, there. We were able to generate the correlation among the different variables. Or another way to do this, pareho lang siya, Control C, Control V. Pwede nating tanggalin, guys, except negative C means do not include columns 4 up to 6. Okay, so the same, guys, the same thing ito. We're getting the correlation among the different variables of the wage object. Include all the rows, but for the columns, just exclude columns. Paano ko nalaman na column to, guys? Kasi yung first location, yung una dito, row yan. Yung pangalawa dito, column. So do not include columns 4 up to 6. Okay? So that's your C, that's your combined concatenator, no? And negative means do not include. Then sarado natin tong subset and sarado natin yung core function. Okay? So okay, when you run this, Control Enter. Okay. It will give us this. No? So the correlation between education and education is of course, 100%. No? And education is correlated to hourly wage. Ito yung nakita natin, now 0.41. And it's not correlated to the other dependent variable, which, guys, is actually good. So I think I mentioned to you before that we don't want the variables, the independent variables, to be correlated with the other independent variables. Okay, ito mukhang yung tenure at saka experience mukhang medyo relatively mataas yung correlation nila, no? And if you take a look at the dependent variable hourly wage, okay, so of all the independent variables, we can see that education seems to be the highest in terms of correlation between hourly wage. Si experience mababa, no? And then si tenure mas mataas. 0.34. Pero ang pinakamataas talaga si education. Si number of dependents doesn't seem to negative correlation nila, and mukhang mahina, very weak yung correlation between number of dependents and hourly wage. Okay? Okay, clear so far, guys? Clear so far about even before going into regression, guys? Kailangan pag-aralan muna yung data, tingnan kung related ba sila. So we're trying to regress hourly wage on education, and we're saying that there's a medium or medium relationship between hourly wage and education. Kasi 0.4 to 1 lang yung correlation nila. Okay? Questions, guys? Questions? Okay, so let's now do the regression model. Okay, regression model natin. Okay, so the formula, we use the LM function. Okay, the LM function. So ano yung LM function? Okay, nag-IntelliStat siya. Yan. Formula, okay, nawawala kagad, no? Of course, we can use this one, formula, and then data, and then if there's a subset, the weights, etc. So ano yung formula natin? Our formula is that our hourly wage, okay, is regressed. Okay, ito yung symbol natin, no? Yan, tilde. Okay, we use the tilde character in order to this indicates that we're regressing hourly wage on education. Yan. Okay, so that's what that means. We're regressing hourly wage on education, comma, and we have to identify our data. Our data is equal to wage. Yan. So very simple lang, guys. Very simple lang ang code sa R. No? LM, hourly wage, regress on education, data is equal to wage. Okay, so let's take a look at this, guys. Let's run this. Control Enter. Okay, and then automatically it will generate the summary of our of the output. No? Okay, so here it calls on the formula. Anong formula daw? Hourly wage, regress on education using data wage. Data is equal to wage. And since it's a simple linear regression, we expect two outputs here: the intercept, and then the slope for the independent variable, okay, which is 0.5414. Okay, so that's the summary output, no, of this regression. Okay, now if you want, kasi may mga ibang output pa yan, di ba? What we can do is, okay, we can call on the insert tayo. Okay, let's insert. Okay, what we can do is we can name this, we can name an object for this. Okay, so here I'm going to create model 1, sabihin natin mod 1, okay, and then we're going to use assignment operator, yung alt minus natin, and then i-copy natin to. There. Okay, so it's the same regression, guys, but we created a model, an object for model 1, called model 1. And then if we want the result, we can do summary mod 1. So what will happen here is that R will generate an object mod 1, and it will contain regression outputs from this model, hourly wage tilde education from the data wage. Okay, and then we can do the summary of model 1. Let's run this. Okay, there. Okay, you see now that there's more to the output than just the summary a while ago. Okay. So first here we have it's a call to the model itself, and then the residuals. We're told that the residuals are, we have minimum, -5.3, first quartile, median, third quartile, and maximum. So these are details about the residuals, okay? And then you have the coefficients, okay? Coefficients, intercept, and education. Then we're also given the standard error, and then the t value, and then the probability. Okay, and then it tells us if the variables are significant or not. Okay. And then we have the figures for the SE standard error, 3.378 on 524 degrees of freedom. Then we have a measure called multiple R squared, adjusted R squared, and then the F stat. Okay. So may I ask you first, guys, did you meet these measures before in your FINSTAR? Did you meet, for example, the adjusted R squared, the R squared, the F stat, okay, the P value, and your coefficient of your simple linear regression model? Kindly chat, please, guys, in the chat box. Okay, yes, good. I know you did, guys, kasi yun ang subject ng FINSTAR, no? Okay, but notice, guys, na medyo iba sa atin dito, no? Yung output easily generated from R. Okay, let me run this again kasi I wonder why it's supposed to increase the width para mas madali makita yung output natin. Okay, let me run this again. Run. Okay, wala pa rin, no? hindi niya ini-increase yung size niya. Surprisingly, because usually when it usually prints it into several columns already. Okay. So a quick question, guys. What's our model now? What's our model? Based on this, okay, so what's our model, guys? How will you write our model? Anyone? What will be our model? Would like to volunteer, guys, to explain what the model will be? What did you learn in your FINSTAR? Kasi ang minomodel natin, di ba, sa hourly wage. Okay? So is the intercept significant, guys? Is the intercept significant? Okay, answer please. Nakalimutan nyo na ba yung FINSTAR nyo? Kasi ang objective natin, guys, in doing regression is to come up with a model in terms of your dependent variable, no? As described by your independent variables or variable as the case may be. And then we'd like to explain yung dependent variable natin using our independent variable. And we'd like also, another objective is to forecast. Forecast natin yung yung dependent variable given values of your independent variable. Okay, so what's our model, guys? So yan ang isa sa main goal ng regression model. What's our model? Anyone? Waiting for an answer, guys, from you. What's the equation of our model? Walang sumasagot, yes. Hello, guys. Hello. What's our model equation? Given this output, given yung output natin ng ano ng model 1 natin. No one remembers, guys? Okay, question muna. Isa-isahin ko yung mga question. Okay, is the intercept significant, guys? Is the intercept statistically significant? Wala makakasagot. Janine, why yes?
Sir, when you before you want to get the line, you need to plot in the graph. And you need to put the intercept so you can draw the line.
Okay. Okay, the answer, guys, is it's not significant, no? How do you know whether a variable or the intercept is significant or not? You take a look at the p-value. Di ba? Ang intercept daw, ang p-value niya 0.187. And the p-value is greater than 0.05. Di ba? Remember, I told you before that when the p is low, the null must go. Ano ba yung null hypothesis natin dito? If you recall, guys, from your FINSTAR. Ang null hypothesis natin is, sulat nga ako, guys. Mukhang, I don't know kung kung hindi nyo lang naaalala or hindi lang na-discuss, no? Okay. So let me guys, kailangan alam natin yung basics ha, kasi pag hindi natin alam yung basics, okay. Let's go back, guys, to the basics, no? Ano ba yung null hypothesis natin for the intercept? Ang null hypothesis natin, beta null is equal to 0. Okay? So this is the null hypothesis for the intercept. This is the intercept. And our p-value is equal to 0.187. And this is higher than 0.05. No? Okay, so our conclusion is that we fail to reject. Fail to reject our null hypothesis that beta null is equal to 0. Okay, ibig sabihin nun, guys, this hypothesis stays. Beta null is equal to 0. Now, how about the null hypothesis for our beta 1, which is your, this beta 1 is now for your education. No? Kasi tinitingnan natin kung statistically significant ba yung education in explaining your hourly wage. The p-value is practically ilan? Let's go back to that. P-value. Okay, this is the p-value. There, education. The p-value is 2e to the negative 16. Anong ibig sabihin nun, guys? Okay, ibig sabihin nun, 0.000, 15 zeros, okay, and then 2. Okay, that's what this means. 2 times e to the negative 16. You follow 2, you put 15 zeros before 2, and then put the decimal place. So that's practically 0, guys. Okay, practically zero. So the probability that the education will be equal to zero, it's zero. So hindi siya pwedeng maging zero. Si education, hindi siya pwedeng maging zero. So ang ano natin dito, diba, sabi yan 2e negative 16. Ibig sabihin nun, ganito yan. 1, 2, 3, 4, 5 hanggang 15 zeros and then 2. There. This is the probability that your beta 1 will be equal to 0. So, anong conclusion natin? Since this probability is less than 0.05, then ang action natin is, ang inference natin is to reject the null hypothesis. So we're saying that we're rejecting the null hypothesis, which is the slope beta 1, which refers to education, is equal to 0. There's strong statistical reason to believe that beta 1, which is the slope for education, is a value other than 0. Okay, guys, you have to review, guys, kasi hindi natin masyadong babalikan yung nasa basic stat, no? So marami tayong lessons na kailangan tapusin, and for us to go back again to your basic stat in your FINSTAR will be we will not be able to cover, guys, some materials pag ganun ang gagawin natin. Okay, so what's our model, guys? What will be our model? Okay, ano ba yung value ng intercept natin? Negative 9.0485. This is your beta null. Okay, it's negative. Okay, so do we include this in our model? The answer is yes, guys. Even if the intercept is not significant, usually sinasama pa rin yan sa modeling. How about this education? Should we include this in our model? Yes, we include this in our model in explaining hourly wage because this is statistically significant. 0.54136. Okay, what's the meaning of 0.54 here? Anyone? Can anyone explain the meaning of 0.54? Can anyone please explain the meaning of 0.54? Anyone, guys? What's the meaning of 0.54? Ito yung equation natin. Hindi nyo ba ano to? Hindi nyo nakuha, guys? Yung pagsulat ng model sa simple regression. Kindly chat, please, kung you were not able to get it. Maglalagay muna ako dito ng ano, para alam ko kung saan yung... Okay. Feedback, please, kung nakuha niyo yung ano. Because I might be assuming, no? I might be assuming na nakuha nyo to tapos hindi nyo man pala nakuha. May I have your feedback, please, guys? Hello, guys. Hello. Sana kung pwede mas mabilis-bilis yung response natin, guys, kasi marami tayong lull time eh. Marami tayong ano, yung I'm not getting any response from you guys. It's just a yes or no. Natutunan nyo ba yan sa FINSTAR or in your previous subjects? Kasi kung hindi, guys, then medyo papasadahan ko ng konti. Pero kung ano, then I'll be assuming already that you know how to construct your Baguhin ko lang to ha. Okay, nakalimutan na. Okay. So, medyo guys, may I suggest that you review it a bit. Kasi guys, medyo itong subject natin na to, advanced na to ha. So, we will not have much time to review, okay, yung dati. Okay, so kindly please, kasi pag re-review pa natin ulit yung mga basics na yan, hindi na natin mako-cover yung mga later topics. So that's the disadvantage. So I'd like to encourage you guys to read up on your previous notes para para medyo nagkakaintindihan tayo, no? Okay. So when we write our model, guys, ito yung dependent variable natin and simple regression lang to. So we have only one predictor. Let me kasi ano lang tayo guys, hindi talaga tayo magsi-simple regression, no? I'm using just by way of review. Okay. So when I asked you a while ago, what's our model? Okay. Kasi di ba pag nagre-regression tayo guys, we're trying to establish the relationship between your dependent variable, in this case your hourly wage, and create a regression line. Di ba sabi natin ang equation na to is beta null plus beta 1 times your independent variable and then plus your error term. Okay? So ito yung equation natin. So writing the equation, hourly wage is equal to, so this is negative 0.90 ba? Plus our beta 1. What's our beta 1 guys? 0. Ano? 0. What guys?
0.54.
0.54 times education. Okay. Plus, okay. So this is your equation. This is your model. Now, we know that your intercept is not significant, no? Not significant to eh. Pero kahit na hindi significant yung intercept, sinasama pa rin natin siya. Pero pag yung independent variable mismo hindi significant, hindi siya pwedeng isama sa equation, no? Since education, the slope of education is 0.54 and it's statistically significant, then valid na isama natin yung education as a predictor of hourly wage. Okay? So what does 0.54 mean? Okay? From your FINSTAR, from your earlier subjects, 0.54, guys, is the marginal effect. Ito yung marginal effect o yung slope natin. Marginal effect of the independent variable on your dependent variable. Ceteris paribus. Ceteris paribus. Did you meet that expression, guys, in your FINSTAR? Ceteris paribus. Pakichat nga please kung na-meet. Para kung... Okay, good. Right, good. So what's the meaning of 0.54? Ang ibig sabihin ng 0.54, this is the effect of education on hourly wage. No? Ang ibig sabihin niyan, for every 1 unit increase in education, there's a corresponding 0.54 units increase in hourly wage. Notice it's increase in education, increase in hourly wage. It can be stated decrease in education, decrease in hourly wage. Kasi positive siya. Ibig sabihin, education and hourly wage move in the same direction. Okay? Now, I said units, guys, kasi dapat ililink natin yung units dun sa independent variable natin at saka dependent variable natin. Now, ang education natin is in years. Okay, so when we interpret this, we say that for every 1 year increase in education, there's a corresponding 0.54 watt. Okay, so it's $0.54 increase in hourly wage because hourly wage is expressed in terms of money, no? Hourly wage to eh. Okay, so that's how we interpret this. Okay, and then how do we interpret this negative 0.90, our intercept? You learned in your previous subject that the intercept is the value of your dependent variable hourly wage when all your independent variables are all equal to 0. Okay, so anong ibig sabihin nito? A person that does not have any education, okay, 0 to, will have on the average an hourly wage of negative 90, negative 0.90. Of course, practically guys, that does not mean anything. No? Wala siyang practical interpretation kasi hindi naman po pwede magka-hourly wage ng negative. Okay, but we just choose anyway the intercept even if it's not significant in describing our dependent variable hourly wage. Okay, now the ceteris paribus here means ginagamit yan pag marami na tayong, pag multiple regression, pag marami tayong independent variable. Kasi ang tinitingnan natin guys, we only take a look at the marginal effect. Ibig sabihin, one at a time lang. Isa-isa lang yung tinitingnan natin na effect ng independent variable 1 on hourly wage, assuming that all the other independent variables do not change. Okay, or do not remain the same. Kasi ito, tinitingnan natin, anong mangyayari kung dinagdagan natin si education ng 1 taon, anong mangyayari kay hourly wage? So that's what this means. If we add 1 year to education, hourly wage will increase by 0.54. Okay? So ang inference nito, pag mas marami kang education na, years of education na idagdag under your belt, mas tataas yung hourly wage nyo. Okay, based on the data na ginamit natin. And by the way guys, actual data to, no? Yung ginagamit natin yon. Pero matagal na yon. Matagal na data to. Okay, pause muna ako guys. Any questions so far? Any questions so far? Okay, clear ba yung ano natin? Okay, thank you. Okay, guys, I'd like to encourage you to review yung mga concepts kasi kailangan natin yon, especially when we go to multiple regression. No? Okay, ano ibig sabihin nito? Very quickly, guys. Ano ibig sabihin ng adjusted R squared na to? 16.32. Anyone? You remember? Okay, adjusted R squared 16.32 is a measure of the capability of the model to explain the variation of your dependent variable. Okay, ulitin ko yun ha. Diba? Kasi ang gusto natin, ine-explain natin yung model natin. Ine-explain natin yung dependent variable natin. Sino yung dependent variable natin? Si hourly wage. Okay? And one measure by which we use in order to describe how powerful your model is use the adjusted R squared. Okay? Saka na natin explain yung multiple R squared, no? But the adjusted R squared tells us that 16.32% of the variation, of the variability of your dependent variable hourly wage can be explained by your independent variable. In this case, isa lang si education. So ang sinasabi niya, si education kaya niyang i-explain yung variability ni hourly wage, 16.32% nun. But the rest, the 83%, hindi niya kayang i-explain. Okay? So in a sense, guys, ibig sabihin nun, there are other variables that could explain hourly wage. Kaya nga, importante yung concept ng multiple linear regression. Kasi in multiple linear regression, we use also other independent variables in order to explain or describe our dependent variable. Okay? Clear so far, guys? Clear so far? Okay. So, i-plot natin, guys. I-plot natin yung ano natin. Plot. Okay, so naka-attach tayo, di ba? Naka-attach tayo. So, plot education and then x-axis hourly wage. Okay. And then x-lab equals years of education ylab is equal to hourly wage. Okay, then main ulit, main is equal to scatter plot of education and hourly wage. Okay. All right. So let's see if this will run. Kaya ba niya mag-run? Kasi hindi natin sinama si wage dito, di ba? Okay. Too large na naman, no? So I need to almost time na. Okay. Saan si plots natin? Okay. Let me run this again. Okay. Ito yung printout natin kanina. Now what we're going to do now is to add, no? Mag-add tayo ng ano, ng function na AB line. Okay. Oops, sorry. So this function is used AB line. Function to na ginagamit para i-plot yung regression line. Isasama natin, no? So AB line ng LM, hourly wage, regressed on education. Okay. And pwede natin lagyan ng color. Color is equal to, gawin natin blue. Yeah. Okay, what are we doing here? Sa plot na to guys, ilalagay natin yung asan yung model natin, asan yung regression line natin. So let's run this. Run. Okay. Okay, if you can see now guys, ito na yung regression line natin, no? Okay. And if you extend this guys, itong line na to, itong blue line na to, yan, it will touch the y-axis on -0.9. Yun ang intercept. And this equation guys is yung equation na hourly wage is equal to -0.90 plus 0.54 times education. That's the equation guys. Ito yun. Ito yung regression line na to. Okay? So time na guys. Okay, so medyo konting review guys ng yung mga equations sa regression. Next week, next Thursday we'll continue with this. We'll take a look at the residual analysis, yung analysis ng error terms natin. Tapos pupunta na tayo sa multiple regression. Okay? All right. Pause muna ako.